Hi everyone, my name is Sabri Nawi from Mechanical Engineering and I will present about Bernoulli's equation. Start with the introduction. Bernoulli's equation is the mathematical derivation from Bernoulli's principle, which states that the sum of all mechanical energies such as kinetic energy, potential energy and pressure head should remain constant at all points of a streamline for a steady flow. This principle follows the law of conservation of energy. Bernoulli's equation is as below. P, which is the pressure head, plus 1/2 density velocity squared 1/2 rho v squared, which represents the kinetic energy, and specific gravity Z. This represents the potential energy. So the sum of all three energies is constant along a streamline. After derivation of this formula, we divide by specific gravity, we will get pressure divided by specific gravity plus velocity squared divided by 2g plus z equal to constant. Bernoulli's principle also states that in a steady flow of fluid, when the velocity increases, the pressure of fluid decreases. There are three assumptions of Bernoulli's equation. First, fluid is at steady flow. Second, fluid is incompressible. This is because density is constant along a streamline. Third, the friction by viscous forces is negligible. Moving on to the objective. This experiment is to demonstrate the validity of Bernoulli's equation using Venturi meter. And second, to determine the relationship between velocity of fluid and the pressure. Moving on to the methodology. This experiment will use Venturi meter, which have converging and diverging parts to alter the area. Theoretically, when the area available for fluid to flow decreases, the velocity will increase and the pressure will decrease. The Bernoulli's equation will be verified by using manometer to measure the pressure head at known points along the Venturi meter. Moving on to the procedure of experiment. First, set up the apparatus as shown in figure. Second, make sure all manometer tubes are connected properly and air bubble free. Third, the discharge valve is adjusted to a high measurable flow rate. Then, after the level is stabilized, the water flow rate is measured using volumetric method. Then the hyperdomic tube is gently slide so that the cross-section of Venturi tube is at #1 reach its end. Then the height of manometer is measured. Step 7. Repeat step 5 to 6 for other cross-sections. Then the velocity is calculated using Bernoulli's equation and also using continuity equation. Lastly, the difference between two calculated velocities is calculated. Next is the setup of experiment, which is the manometer, the Venturi tube or the test section, the water inlet, the discharge valve, and also adjustable feed. Moving on to the result of experiment. In this experiment, we use the flow rate Q equal to 9.509 times 10 to the power of -5 meter cubic per second. So, in the result, we will calculate the velocity using Bernoulli's equation, which is V equal to square root 2g h1 minus h2. We also calculate velocity using continuity equation, where V equal to flow rate Q divided by area. Then we will calculate the difference between V1 and V2. As you can see, when the area is the smallest, which is at cross-section 3, the velocity is the highest among the other cross-section area. This shown that when the area decreases, the velocity increases. We also calculate the pressure using formula P equal to density times G times height of manometer. Moving on to the discussion. From result of experiment, when the area of fluid flow decreases, the velocity of fluid increases. Next, The velocity of fluid is calculated using two different formula, which is Bernoulli's equation, where V equal to square root 2g h1 minus h2, and using volume rate equation, where V equal to flow rate Q divided by area, and the pressure is calculated using formula P equal to density times G times height. Moving on to the conclusion. First, smaller area produce high velocity of fluid. Second, pressure is inversely proportional to the velocity of fluid. And third, Bernoulli's equation is verified. That's all from me, Sabri Nawi, about Bernoulli's equation. Thank you for watching.